In April 2019, a pair of Eurasian beavers from Scotland were released into a fenced enclosure in Cropton Forest, North Yorkshire. 10 hectares of conifer plantation surrounding 800 meters of a small stream called Sutherland Beck. The stream was already lined with man-made flood defenses, timber bunds, and large woody debris dams that engineers had built by hand starting in 2009 as part of a project called Slowing the Flow. Those structures existed for one reason. A catastrophic flood in 2007 had sent water roaring through the nearby town of Pickering, causing roughly £7 million in damage to homes and businesses. The wooden dams worked. They slowed the flow, but they were degrading. By 2023, forest research assessments confirmed that both timber bunds had deteriorated significantly and were approaching the end of their effective lifespan. Replacing them would cost money, time, and heavy machinery. The two beavers were released to answer a question no one in Britain had ever formally tested. Could a pair of animals do the job of an engineering team and keep doing it year after year without maintenance budgets, without replacement schedules, without anyone coming back to fix what the weather broke? Within 5 years, the answer was in the water. The beavers built 4 major dams across the valley floor. The largest, Dam Number 4, spanned 60 meters across the floodplain, stood over 3 feet high, and held a permanent pond estimated at 837 cubic meters of water. Across all 4 structures, total beaver dam storage reached approximately 2,280 cubic meters. Frog spawn on the site went from 6 countable clumps before the beavers arrived to an uncountable mass by 2021. Noctule bats were recorded for the first time in 30 years. An otter family moved in. The family of 2 had grown to 10, and the peer-reviewed science confirmed what the site ecologist described in 4 words: changed beyond all recognition. This is the complete account, from the 2007 flood that started the search for a cheaper way to protect a Yorkshire town, to the timber structures that worked but could not last, to the 2 beaver experiment that replaced them with something self-repairing, self-expanding, and free. Other videos about beaver flood management show you a pond and tell you it helps. This one tracks the engineering data 5 years deep into the hydraulic modeling that compared beaver dams against man-made bunds, the multi-site peer-reviewed study proving beavers reduce peak flows by up to 60% even in the largest storms, and the biodiversity explosion that no flood management plan had budgeted for. The evidence behind every claim draws from Forest Research's 2024 Beaver Dam versus Timber Bund Storage Analysis, the Puttock et al. 2021 multi-site study in hydrological processes, and Forestry England's official trial monitoring records. None of this is speculation. This is what the flow gauges, the survey data, and the ecological monitoring actually document. To understand why 2 beavers in a Yorkshire forest matter, you first need to understand the problem they were brought in to solve and why the conventional solution was already failing. Pickering is a market town of roughly 7,000 people, sitting at the southern edge of the North York Moors. The rivers and becks draining the moors run south through steep, narrow valleys before reaching the low-lying farmland around the town. When heavy rain falls on saturated ground, which, in a climate change-driven era of more intense and more frequent storms, happens with increasing regularity, the water rushes off the moors, concentrates in the valleys, and hits Pickering fast. The 2007 flood was the worst in living memory, but it was not the first, and everyone involved knew it would not be the last. The Slowing the Flow project, launched in 2009, was one of the first natural flood management programs in Britain. The concept was deceptively simple. Instead of building expensive concrete flood walls downstream, slow the water upstream using low-cost natural features. The team planted 18.5 hectares of riparian woodland. They constructed roughly 130 large woody debris dams across tributaries. They installed over 130 heatherbale check dams. And in Sutherland Beck, they built 2 engineered timber bunds, larger structures spanning the full width of the floodplain, designed to hold back significant volumes of stormwater. The project worked. Pickering did not flood again at the 2007 scale. The approach was celebrated nationally as a model for natural flood management across Britain. For Americans watching the increasing frequency of catastrophic flooding across the Midwest, the Southeast, and Appalachia, where communities face the same impossible calculus of cost versus protection, the slowing the flow concept is directly relevant. It is cheaper than concrete, it uses natural materials, and it works. There was just one problem. The structures were dying, timber in water rots. The 130 woody debris dams needed periodic replacement. The 2 engineered bunds, built from heavy timber in 2011, were assessed by Forest Research in 2020 and again in 2023, and found to have degraded significantly. They were reaching the end of their effective life. Rebuilding them would require machinery, labor, and budget. And every other structure in the catchment faced the same trajectory, a slow, inevitable decline that would eventually undo the protection unless someone kept coming back to fix it. The question the Cropton Forest trial was designed to answer was whether a biological system could replace a mechanical one, whether an animal that builds dams instinctively, repairs them constantly, and expands them as its family grows, could deliver the same flood attenuation as an engineered structure and sustain it indefinitely without human maintenance. The recovery effort that brought the beavers to Cropton was a partnership between Forestry England, Forest Research, the University of Exeter, and beaver specialists Dr. Roisin Campbell-Palmer and Derek Gow. The enclosure was purpose-built, securely fenced to prevent the beavers from dispersing into the wider landscape during the trial period. The stream already had the man-made timber structures in place, which made it the first site in Britain where beaver interactions with existing flood defences could be scientifically measured. The 2 Scottish beavers were released in April 2019. They produced 2 kits that year, 2 more in 2020, 4 in 2021, and 2 in 2022. By 2022, the family numbered 10, though the 2019 juveniles were relocated to other English projects. The population within the enclosure stabilized at a working family unit. The population numbers, though, were not the revelation. It was what the animals constructed and how it compared to what the engineers had built. The beavers did not adopt the man-made structures in the way some researchers had hoped. They did not simply maintain the existing timber bunds. Instead, they built their own. 4 major dams, positioned at locations the beavers selected based on stream gradient, channel width, and available materials. Dam 1 sat at the downstream limit of the enclosure. It was 0.6 meters high, spanning nearly 25 meters across channel and floodplain, holding roughly 242 cubic meters of permanent ponded water. Dam 4, at the upstream end, was the largest beaver dam in England. It was 1.07 meters high, stretching 60 meters across the valley floor, holding 837 cubic meters of water behind it. Combined, the 4 dams stored approximately 2,280 cubic meters of water. Forest Research's 2024 analysis modeled the comparative flood storage performance of beaver dams versus the man-made timber bunds using FEH-generated flood frequencies. The results showed that the beaver dams provided comparable or superior storage to the engineered structures, and critically, the beaver dams were gaining capacity over time as the animals expanded and reinforced them, while the timber bunds were losing capacity as they degraded. That expansion is where the science starts getting genuinely surprising. Because the Cropton trial did not exist in isolation, it was part of a broader body of peer-reviewed research centered at the University of Exeter that was simultaneously documenting beaver flood attenuation across multiple sites in England. On the ground level, the first finding was hydrological. The Puttock and others study from 2021, published in Hydrological Processes, analyzed beaver dam impacts on peak flows across several English sites using additive regression models. The results were statistically unambiguous. Beaver dams significantly reduced peak flows. Estimated reductions ranged from modest to substantial, depending on site conditions, but even during the largest storms monitored, events where conventional wisdom assumed beaver dams would be overwhelmed, peak flows were attenuated by up to approximately 60%. The effect persisted in wet conditions when the ground was already saturated and the conventional expectation was that additional water storage would be impossible. For Americans managing flood-prone watersheds, the implications are immediate. The United States spends billions annually on flood infrastructure, levees, channels, and detention basins that degrade, require maintenance, and often fail catastrophically when overwhelmed. A biological flood management system that self-repairs, self-expands, and costs nothing to maintain after installation represents a fundamentally different economic proposition. The Cropton data, combined with the Puttock multi-site findings, provides the most rigorous peer-reviewed evidence to date that such a system actually works at catchment scale. The flood data, however, was only half the story. What the beavers did to the biology of Sutherland. Beck was something the flood engineers never planned for. Frog spawn went from 6 countable clumps to an uncountable mass, providing a food source that attracted up to 15 herons, an otter family, badgers, and owls to a stretch of forest stream that had previously supported almost none of those species at those densities. Nocturnal bats, a large, high-flying species not recorded in the area for 3 decades, reappeared. The felling of trees by the beavers opened canopy gaps that triggered the growth of foxgloves and other light-demanding plants. Aquatic and wetland species colonized the new pond margins, water plantain, tufted forget-me-not, and water starwort. Butterfly diversity increased. The site ecologist for Forestry England, Kath Bashforth, described the transformation as a complex mosaic of habitats where before there had been a uniform conifer stream. The third revelation was economic, and it may be the finding that matters most for policy. Man-made natural flood management structures work. The Slowing the Flow project proved that beyond doubt, but they have a finite lifespan. Timber rots, heather bales decompose. Woody debris dams shift and fail in major storms. Every structure in a natural flood management scheme requires periodic inspection, repair, and eventual replacement. That maintenance costs money, money that local authorities in both Britain and America rarely have in sufficient quantities to sustain indefinitely. A beaver dam does not rot because the beaver repairs it. A beaver dam does not fail permanently because the beaver rebuilds it. A beaver dam does not stop expanding because the beaver keeps adding material. The cost of a pair of beavers, including capture, transport, veterinary screening, and enclosure construction, is a one-time capital expense. After that, the maintenance budget is zero. The beaver works for free. It works at night. It works in winter. And it produces, as an incidental byproduct of its own survival behavior, a flood management system that simultaneously generates biodiversity, carbon storage, water quality improvement, and drought resilience, none of which a timber bund provides. The Ojibwe word for beaver is Amike. The Old English is Beofor, the root of place names scattered across England from Beverley to Beverston, names that survived 4 centuries of the animal's absence from the landscape. At Cropton, the name that matters is Sutherland Beck, a stream so small it barely appears on most maps, running through a conifer plantation that most people in Yorkshire have never heard of. But that stream now holds the most comprehensively monitored beaver flood management dataset in England. And what it shows, in peer-reviewed, hydrologically modeled, and ecologically surveyed detail, is that 2 animals, given 800 meters of stream and 5 years of freedom, built something that outperforms what a team of engineers constructed with heavy machinery and public funding. 2 beavers, 1 stream, 5 years, 4 dams holding 2,280 cubic meters of water, a flood management system that repairs itself, expands itself, and generates biodiversity as a side effect of its own existence. And a question that every flood-prone community in Britain and America will eventually have to answer: why are we building structures that rot when we could be releasing animals that do not? England is not the only place where a returned species is transforming a landscape in ways no one anticipated. In our next video, we go to Idaho, where in 1948, a state wildlife officer threw 76 live beavers out of an airplane with surplus World War II parachutes, dropped them into a valley that would become one of America's largest protected wilderness areas, and accidentally started an ecosystem restoration experiment that has been running uninterrupted for 77 years. If you thought 2 beavers in a Yorkshire forest could outperform a team of engineers, wait until you see what 76 parachuting beavers did to 2.3 million acres of American wilderness when nobody was watching. You will not look at flood management the same way again.